Hey guys, my friend John, welcome back to another video, and today we're going to be talking about some game mechanics as the things that go on behind video games. Now we're going to be talking about a new technology that's called ray tracing. Now, what is ray tracing? Now, you all know about video games, right? Their graphics. They may be not so realistic, but as you know, they've been improving throughout the years. This is one of the main tactics that they're using in order to improve. This is one of the newest technologies on the game market right now, and it's only available on the highest end GPUs. It is called ray tracing. Now, what is ray tracing? According to Wikipedia, ray tracing is a rendering technique used for generating an image by tracing the path of light as pixels in an image plane and simulating its effect is encounters with virtual objects. I know that's hard to understand, so again, let me break it down. So what it does is it traces rays. I've mentioned this in the new video that I posted yesterday, Tech News number 1. So what it does is it traces the rays. It basically puts the rays into the scene, and it tries to it estimates the color of the pixels, right? So for example, take my hand for example. What color should be here for this pixel? It's not a real it's not a pixel, but on the screen will be a pixel, right? For this pixel, what should be the color? So the computer very label intensively estimates that by literally calculating all the light rays. So what do the light rays do? So are they being on the way to the lights to the actual object? Is the light being refracted, or like so you see, a lot of things can happen to light, right? It can either be blocked, which causes a shadow. It can either be refracted, which causes the light to bend, or it can be absorbed. So the computer tries to figure out which is happening. So it tries to estimate how it's going to look, right? It's a lot of math. If you go to the Wikipedia page right now, there is so much math on it. Like there are like huge calculations. The computer has to do all of that, right? Now, Nvidia, which makes the GTX graphics card, which are like the highest end in the market, has released something called the RTX 2080, which is one of their highest higher end GPU models. That is one of the few ones that can do ray tracing really well. But ray tracing is not new to the market at all, right? Ray tracing used to be used in Hollywood films to make sure to blend in the computer graphics from the real world. For example, let's say this is a scene, right? And I just add in a fake ball here. Then it has to be blended in with the actual environment. So ray tracing was used to do all of that in films, but that was so computationally intensive that it took many days, even weeks, to render with a normal rendering workstation, right? So that's how labor intensive this is. But what we are talking about is real-time ray tracing. It happens just as you play the ray tracing, right? It makes something look extremely better. It looks absolutely like it looks very real. It adds a lot of realism to any game scene. That's why it's so impressive, right? It may even take days, weeks to do it in Hollywood movies, but now the computers have improved so much that we can do it in real time. That's how good ray tracing is happening. Now let's see how ray tracing happens, right? So let's say there's a scene, right? So the computer places rays inside of it. It sees where the light source is. In my case, the light source are these tube lights on the either side of me. So it just sees where the light sources are, and it puts just rays that it estimates, like all these rays are coming in, right? And it traces the path of those rays, whether they're getting refracted, absorbed, or is some fluorescence happening. So what is fluorescence, right? Fluorescence is an interesting thing in science. When an object reflects it, absorbs it, and then it gives it out later. But that is actually out of the equation here. So it tries to see whether the light ray has been either reflected, or has it been absorbed by the object, or is the object something like water or glass that can actually refract it. Sorry. So ray tracing. So the ray tracing algorithm takes care of all of this. So if the light is being blocked by my hand, it places a shadow in the back, right? Or if it's being refracted, it just adjusts the environment so that it's accurate to that. Now, on the NVIDIA website, there's a lot of information about ray tracing, right? You can actually, if you have a pretty higher end PC, you can probably do ray tracing right now on your PC. Now, our graphics card have gotten so good that you can actually do ray tracing for Minecraft when you have a GTX 1060 6GB. But but not a lot of many people may have that. So we can have a simulation of that, which we will see later in this video. So now ray tracing makes it look much more real. But now we already have pretty realistic video games, right? So what is the method that is being used currently, except ray tracing, to actually do it? We use a method called rasterization. So what rasterization does is, it doesn't have any perfectly round objects. It takes it as different, very dense polygons. And through this, the computational workload can be reduced significantly. So it thinks every object is like a dense set of polygons. So that's what it takes it as, and that reduced the workload a lot, right? But now, as our technology is increasing, right, it keeps on going up. We are able to do ray tracing, which makes it look much more real. So how much more real does it make it look? You can see some images of ray tracing done on objects. It's actually rendered, it's not real time. Now I'm going to show you what a simulation of ray tracing looks like in a game. You know that I mentioned earlier that up to GTX 1060 6GB you can do, but unfortunately mine falls short. It's at 1063GB, so I unfortunately cannot do the actual ray tracing, but I can at least do a simulation of ray tracing. If you look at this, that's my cat, right? That you can see that it casts shadows, which it doesn't do in Minecraft. Now let me show you what this is supposed to look like without ray tracing. Or ray tracing. This is a simulation of ray tracing. It's called a shader. You can install this at home too. This is how it looks, right? It doesn't it casts a shadow, but it's just a circle around me, so it doesn't look very real, right? It looks blocky. That's the charm of Minecraft, right? It looks blocky and stuff. That's totally okay. But if we turn the shader on, or the simulation of what ray tracing is supposed to look like, you find that everything looks better, right? And you can also see my frame rates are dropping. You see, I used to have around 600 frame rates. Now I only 400, 200, 600 frame rates. A lot of frame rates because Minecraft doesn't take a lot of computing power. But now you can see that the frame rates have dropped significantly. Now let's test a thing called rendering. Now rendering is, now you see how a game works is, it doesn't, currently if you see over there, you can't see a lot of things, but now just things are just popping in, right? Because the game doesn't load everything in the world, because that will take some time. But only when you move close to that, you can just see things just popping up, right? So that is rendering. Now I'm going to show you an extreme example of rendering. Now I am in this dimension, it's called the overworld, but now if I go into the nether, it will take a lot of time to render with ray tracing, because it's like a new environment, right? It has to render in everything at once, and it takes some time because I have this simulation of ray tracing on. Look at this. Normally you can see it's just an orange glow, but if I do this without the simulation of ray tracing, it should just pop right in. So if you just wait for a while, it'll render everything in. So it has to, there you go. So it just renders everything in. And I also wanted to show you how living things or mobs affect lighting. If you can see that, okay, as he walks it okay, you see mobs cast lighting, they cause a shadow, right? Because they are an obstruction in the path of light. That's what ray tracing does. Now unfortunately it looks like in the nether we cannot actually simulate that. So if we go back into the actual overworld, the dimension, we can see that I myself am a mob. So you can see the shadow of the player, which is me. You can see it as I walk, my shadow also moves, which is cool. So now I'm going to spawn in a bunch of mobs, and you can see, oh god, okay, so you can see all these creepers. See, that casts a shadow over that sun, right? You can see this shadow because the ray tracing algorithm is figuring out that, okay, the creeper is here, the light is being blocked by that creeper, so we should create a shadow. So that's what's happening here. You can see that this rabbit also casts a shadow. Even a turtle causes a shadow. What else? We have a silverfish. Sorry, the silverfish that also casts a faint shadow. You can see all of this is amazing, right? And if you go over here, you can see that there's some lava, right? That causes a faint glow because it recognizes that the lava is actually a source of light. So you can see that it casts a sort of orangish glow over this area because it recognizes this as a source of light. Again, I want you to know that ray tracing is actually much better than this, but unfortunately we are not able to get ray tracing. If I could have, I'd have got ray tracing, but we don't have ray tracing. So ray tracing actually looks a little bit better than this. Because I mean, again, if I could actually do ray tracing, my computer will take a big hit, right? But again, it's a very close simulation of what ray tracing actually could look like. It's a very close simulation, right? So see, our computers have evolved so much over the decades, and it's just so amazing to see all this. Right now, again, let's check rendering again. If we check how that area renders, if you can see that things just pop up. And see, when you do ray tracing with not a powerful enough GPU, there's a problem because over there it hasn't loaded in it, so it cannot cope with how fast I'm traveling. So there's a problem. Only if it goes so close does it render in the things beyond this horizon. So that just becomes a big issue. So ray tracing has a few issues. One, it takes so much performance to like render everything, right? So that's a bit hard. But there are like also many other reasons. But still, ray tracing, again, as I've said, our GPUs have improved so much. It's almost it's not an if, it's a when for ray tracing. When ray tracing improves, everything's like can be so much better. So I think it can be much better. It's going to be much better. So that's nothing to worry about there. And so guys, yeah, if you have like a good enough GPU, you can do ray tracing on it right now. So yeah, ray tracing is an absolutely wonderful technology that allows us to create realism in games, in movies, in all sorts of media that we love. It makes it look much more real and puts us into those worlds, right? It's an absolute great feat of mankind, and hopefully it keeps getting better and better. And I hope you guys enjoyed this video, and if you did, please be sure to hit that like button and to subscribe, and I will see you in the next video. Bye.